Physics Part 171. So we'll talk about the properties of reflection, refraction, diffraction and interference to demonstrate wave properties. Let's talk about reflection first of all. As the waves strike a plane barrier placed in the water, they are reflected. The angle of reflection equals the angle of incidence. There is no change in wavelength. If a curved barrier is used, the waves can be made to converge or diverge. It is also shown in the figure. Ripple tag pattern showing reflection at a plane surface and at a curved surface. Refraction. If a glass block is submerged in the water, this produces a sudden change in the depth of the water. The speed of surface ripples on water depends on the depth of the water. The shallower the water, the slower the speed. Thus, the waves move more slowly as they pass over the glass block. The frequency of the wave remains constant, and so the wavelength decreases if the waves are incident at an angle to the submerged block. They will change direction. The change in direction of a wave due to a change in speed is called refraction. As the waves re-enter the deeper water, their speed increases to the former value. They change direction once again. Diffraction. When waves pass through a narrow gap, they spread out. This spreading out is called diffraction. The extent of diffraction depends on the width of the gap compared with the wavelength. It is most noticeable if the width of the gap is approximately equal to the wavelength. Diffraction is illustrated in the figure. Diffraction will be considered further in our upcoming section. Diffraction is defined as the spreading of a wave into regions where it would not be seen if it moved only in straight lines. Next we've got interference. If two or more waves overlap, the resultant displacement is the sum of the individual displacements. Remember that displacement is a vector quantity. The overlapping waves are said to interfere. This may lead to a resultant wave of either a larger or smaller displacement than either of the two component waves. I beg your pardon, please. Interference can be demonstrated in the ripple tag by using 2-point sources. Alhamdulillah, alhamdulillah, alhamdulillah. Our figure shows such an interference pattern, and figure shows how it arises. Another figure shows how it arises. Interference will be discussed further in our upcoming section. We've got section summary for you. A progressive wave travels outwards from the source, carrying energy but without transferring matter. In a transverse wave, the oscillations are at the angles to the direction in which the wave carries energy. In a longitudinal wave, the oscillations are along the direction in which the wave carries energy. The intensity of a wave is the energy passing through unit area per unit time. Intensity is proportional to the square of the amplitude and to the square of the frequency.